Good morning. Welcome. I'm Chris Williams from the LYCRA Company. I've been with the company for just more than 30 years now, from the technical department, supporting the trade, the mills, helping with technical issues and rolling out new products and processes. So this morning I'm going to talk to you about our sustainable stretch technology, which covers both our bio-based lycra fibre. We also call that our bio-derived lycra fibre, as you'll see in the presentation. We use the term bio-derived. Then also I'll be talking about recycling of lycra fibre. We know it's an issue in the trade at the moment of recycling of lycra fibre in garments and fabrics. So I'll talk about what progress we're making on that in terms of recovering and recycling lycra fibre. So why are we doing it? Back in 2008, we drew up our sustainability platform, which we call Planet Agenda. And that's split into three main pillars. We have corporate responsibility, which is all about fair and ethical treatment of our employees, responsibility for the community we operate in, both locally and globally, and also trying to promote and drive sustainability. Also, manufacturing excellence is the next pillar. Is all about having very efficient processes to use the least number of resources, water, energy, to produce our products, to be very efficient in what we're doing. Obviously, both makes a business sense to do that, but also from a sustainability and environment point of view. And also, the last one is product sustainability. This is about the products we make, we deliver to the marketplace. And that's split up into, again, different pillars. We're looking at the use of the raw materials for making our products. How easily is it to actually process our products into garments and fabrics? The garment life, the durability of our products in use. If you have a longer garment life, it makes sense. So you don't have to replace the garment, use valuable resource to replace that garment. And then obviously at the end of life is recovering and recycling those essential ingredients to reuse and make again into new garments and fabrics. So part of that Planet Agenda, we set some tough sort of carbon emission targets for 2030 in only 6 years' time. We committed to a reduction of 50% carbon emissions in Scope 1 and Scope 2 and 25% in Scope 3, which is quite tough targets to meet, but we're on track with that. We've signed our Science-Based Target Initiative commitment letter, which has all been approved. And we're on target to meet, hopefully, those goals in 6 years' time. To achieve those goals, we looked at the main contributing, which is our raw materials. Our raw materials, in fact, make up 60% of our carbon emissions. So that's something we need to focus on. So here we have our product vision. So as it said, we're looking at both our raw materials, looking at our renewable or recycled resources instead of using virgin oil. During the garment life, during the garment manufacturing the garments, prolonging that life of the garment. It makes sense to have the garment that lasts longer during wear. So encouraging the consumer to buy smarter, buy longer-lasting garments. Okay, and then at the end of that life is actually recovering those raw ingredients to recover and recycle, to close the loop, to remake new garments again. That's our vision. So, concentrating on our raw materials, we have, in partnership with a company called Core, we have developed a new renewable bio-based lycra fibre made from corn. Okay, so To give you a better insight to what we're doing, hopefully this video works. So, I hope you find that interesting. So, what is dent corn that we're using is actually not the corn that you and I would eat. It's not edible corn. It's a different type of corn. It's a hard corn that's normally used for producing ethanol and animal feed, so it's not in the food chain whatsoever. It's already been used for industrial use. We're just using a small portion of that production process for our use in our LYCRA fibre. We're obviously working with the farmers. We have close relationship with the farmers, making sure they use good farming practices, the good citizens of where they are. So if I go into, so you've seen that in the video that we're taking just over 60% of the total quantity of the corn. It's the starch component that's converted into the raw ingredient for LYCRA fibre. The other components go into other end uses such as corn oil, which you use for cooking and other applications, and approximately 20% goes into animal feed. So let me introduce you to one of our farmers, Steve Kuiper, who will hopefully tell you better than I can the farming practices they use during the growing of the corn that we use in our LYCRA fibre.
As a farmer, it's important for me to be a good steward of the land. One thing people don't realize is a big chunk of products that are made out of petroleum can be directly replaced with products that are made of corn. Hi, I'm Steve Kuiper. I'm a fourth-generation row crop farmer. We're at my grandparents' farm, which is the farm where my great-grandfather settled in. You just look behind us and look at the scenery you have here. You know, Iowa's a beautiful state to live in. You got some of the most productive ground in the nation here. We do a corn-soybean rotation, and when we go to soybeans, we'll vertical till our corn stalks, and then we'll also incorporate rye as a cover crop. It makes the soil easier, more productive for corn, but soybeans also put a lot of nitrogen in the soil. It builds our organic matter in our soils and just makes the farm a lot better. We're currently experimenting a lot with biologicals. There's a lot of nutrients in the soil, but it's tied up. A biological will release that nutrient and get it to the corn plant where we're not relying on commercial fertilizers. So as far as sustainability goes, we can produce corn on every acre that we have today. We don't have any soil loss. We raise hard dent corn for, some people raise it for feed. Some people raise it to go into manufacturing. Companies can take the kernel of corn and essentially break it down into all of its individual little elements. So all the little pieces of that kernel can go to directly replace anything that we currently manufacture out of petroleum. You know, I'm glad that we can be a sustainable part of the consumer's world. So yeah, I'm excited about our products being used in sustainable fashion. You can produce 4,000 different things out of corn, and if we can make life for our consumers better, I think that's a win for everybody.
So, what happens to the corn once it's grown? We have several partners in that chain to make it happen, to turn that into lycra fiber. So, in that chain, we have Cargill, who are actually located on the same area of the farmland where they take the corn and then fractionate it. You just saw the term fractionate it into its component parts. We take the starch out of the corn. And then that's converted by core into the called LYCRA, which is the bio-derived BDO, which is butanediol, which is one of the raw ingredients for making the central ingredient for lycra fiber. That bio-BDO is then converted by another partner, DCC, which converts that into bio-PTMEG, which is glycol, which is one of the key ingredients for lycra. It makes up about 70% content of lycra fiber, the key ingredient. And then, obviously, we take that glycol, mix it with another 30% of other ingredients to make our lycra fibers. So that's the whole process chain from farm to fiber. Once we have made the product, we will be pursuing the appropriate third-party certifications in terms of the USDA BioPreferred, which is actually confirms the bio-derived content. The ISCC Plus will assist in providing the traceability, which is important, particularly for downstream, to ensure that it contains a renewable source of ingredient. And also entering that product into the HIG Material Sustainability Index to help designers to factor that in part of their choice of materials. Okay. So what's the benefits of doing it? We are doing this at scale. We are making a big commitment, a big leap of faith. We're going to convert most of our manufacturing process to the bio-derived lycra fiber. So it's a big leap. So, but we think it's the right thing to do. Moving away from oil, reduce our emissions, move into a renewable source of ingredient. And with that, we've able to calculate that by going to a renewable source away from oil, we can save up to 44% of our carbon emissions by moving to a renewable source. And finally, because it's a raw ingredient, that goes into the fiber, we spin it exactly the same way as we would do with our standard oil-based ingredients. Therefore, the products that we make are completely exactly the same as our standard product. So it's a straight drop in. There's no difference in fiber properties. So it shows no impact whatsoever to our mills, to the garment properties. So where are we with it at the moment in terms of the timeline? We announced the collaboration with Core back in 2 years ago. And for the last 18 months, we've been gathering commitments from mainly brand and retail to sign up to this, to get them on board with what we're trying to achieve and trying to deliver to the marketplace for a more sustainable offering to the marketplace. And then from next year, second half of next year, we'll be moving to full-scale production. We will move in whole plants to produce the bio-derived lycra from one plant at a time, eventually scaling up globally to all our manufacturing process. So what's next? So obviously during that time we'll be scaling up to our different plants, but also looking further ahead. We'll be scaling up all of our sort of standard lycra products, our run-of-the-mill products. But we also have, within our range, we have lots of specialty products that you see on show here at the exhibition. We will also be converting those over to the bio-derived versions as well in time of the next 20 months or so. And then obviously looking at the next phase, end of life, is about we have a renewable source raw material, but also what happens to end of life. So we're also looking at another work stream, looking at how do we recycle that. So trying to recover and recycle the bio-derived LYCRA so it closes the whole loop again to reuse again. Which brings me on to our final subject, which is about the challenges in the marketplace we have with recycling garments and fabrics which contain elastane and LYCRA fibre. So what are we doing on that? So there's two ways of recycling LYCRA. One is pre-consumer or post-manufacturing process, and obviously the most challenging is post-consumer. We already have a pre-consumer during the manufacturing process. We're able to recycle any waste we have. Fortunately, we're very good at what we do. We have very little waste. We're very efficient at what we make. We have less than 1% waste during our manufacturing process. So we have limited quantity of material to recycle to put back into the yarn. So there's limited availability of that. So, and obviously, our goal is to have 100% yield, no waste whatsoever. We want to drive 100% yield, so there's no need to recycle. But at the moment, the very little waste we have, we're able to recover and put back into the process. So the main issue obviously is post-consumer, the fabrics and garments. And there's different levels of fabrics containing elastane. So you have fabrics typically have between 2 and 5% LYCRA fiber content. It's more easy to recycle, mechanical recycling, and that the small amount of elastane in there is waste, and you're able to recover the cotton or polyester or the other component that's in there. Somewhere in between 5 and 10% tends to be sort of downcycled, shred up, and then used in packaging or insulation or something like that. But the main issue is any fabrics, garments containing greater than 10%. It seems a shame to throw that away when you have 10%, more than 10% of LYCRA fiber. It's a valuable resource that you want to recover and reuse. So we're looking at that as one of our key targets. So where are we in that? We are working closely with recyclers. Obviously, we're not a recycling company. We have to work with third-party recyclers, looking at how different ways and how we can recover LYCRA fiber from fabrics and also garments initially. This is a long-term project. It's going to take time. It's not a quick fix. But the idea is to gather garments, sort them, and then break them down, normally chemically, and then split out the different components. So what will happen is the recycle will keep all the other fiber types and hand us the LYCRA fiber component that we can then reuse in our spinning process. So we have done some lab scale tests. We have demonstrated it can be done. We've taken out the LYCRA fiber from garments and fabrics with a high content of LYCRA, and able to dissolve that out, and then put back into the manufacturing process to make LYCRA fiber again up to about 50% content. With any more than that, it starts affecting the properties of the fiber itself. So we can put in up to about 50% content. Obviously, the limitations at the moment of scaling that up is the infrastructure that we have in place of actually collecting and sorting the material, the raw material, the garments, the high LYCRA fiber containing fabrics and garments as the feedstock to make the recycled LYCRA fiber. We're still a long way off. It's not a quick fix, but I think we're on the right path, each step by step. Okay. So, open the floor to any questions. Charles, any questions?
I was talking with the next guys coming on stage. More importantly, you now have Chris on stage, and Chris has been quite modest. One of the massive questions around the whole of the spandex industry, they take a lot of bad views because they're using virgin petrochemicals. The move that LYCRA are doing to trying to iterate to better should be congratulated. You've tried recycled, you've tried bio-based, you're still open to even more invitation. It's a problem which, if they solve, it actually helps the whole of the industry. So I'm really glad of the iteration going on. Now, Charles is filling because I'm seeing no hands go up for questions. And if you don't ask questions, I do. And Chris would much rather listen to your questions than my questions. So you've got the opportunity now, someone at the leading development of potentially the biggest elastane brand. Does anyone want to ask anything? If you don't, Chris will be here after the presentation, so you can always ask him one-to-one. But no one's putting up their hand. So, sorry, Chris, I'm going to start to pick on you for what I know. I know you're only telling us part of the story with the progress. If I was to say, in a year's time, which area that you have not told us about could offer us greater potential? What you've presented to us is where you are confident, where you're working. Are you allowed to give us hints about where some of those weird projects are at the moment? Whether they're successful or not, but I want to open up the thinking and show how wide the LYCRA perspective is.
In terms of the bio-derived, we're on the path, we're there, we're ready to go. It's just a case of pressing the green button for full production next year, and then committing. It's getting the buy-in from the trade as well, because there's a cost involved. We're taking a big hit in cost because it costs more for us to produce than oil-based, but we think it's the right thing to do. We're committed. We're going for that now. So,
but on that subject of bio-based, is it just PLA? Do your customers want genetically modified out of it, or are they not interested? And you were throwing in regenerative agriculture, which is even better. So to come back to the original thing, what's the status of the GM effect on PLA at the moment? PLA is when you take the shards off, when you take the fruit off the corn, it is the starch of the shards. And that's where we're using food waste in the textile industry that shows great interest.
Yeah. GM as a mixed reception, as you know. The corn is GM because
we need to feed people on this planet.
Exactly. And
if we don't produce it.
Yeah. And it makes it resistant to certain pests. So no need to use the fertilizers, the pesticides, which are probably worse than anything really. So, and more resistant to drought as well, because obviously the crop is fed by natural rain. There's no irrigation, so we're not using valuable water resources. So it's optimized for high production with limited low resource to produce that. So it's low impact. So that's why we're looking at that as a solution for low impact right at the very start of the manufacture of the corn, right through the process. Yeah. So we have to look at every step of the process, what contributes to, reducing resources, then shall I say, yeah.
And if I throw in the curveball, for those of you who aren't up to date on status, we've got about 8 billion people on this planet. We still have 1 billion people living below the nutritional poverty level. So I'm quite happy to take on a debate about people who say we only need to have the best food. We need to feed people first and foremost, and you're using food waste, which makes it even better.
Well, we're using product that doesn't go into the food chain. it goes into animal feed.
which is then the food chain. So you are
Yeah, I suppose, yeah.
an
Yeah, I suppose so, yeah.
initiator
Yeah,
of it.
yeah,
So
yeah,
we need to
yeah.
keep up the production.
Absolutely,
So
yeah.
we're happy. But Charles is filling. I'm seeing no questions. You have the wisdom. Oh, you do.
Hey, I have a question. Did you done the trials from rapeseed, for example, or resin when it comes to bio-base, or only corn?
Only corn, we see that as a right way to go. And
Why?
I need to ask that question.
Sorry, I'm going to step in and help here. So corn is produced massively. When you look at the corn production in the US, for example, so we're going to be sourcing from farms within a 100-mile radius of our plant in Iowa. 99% of corn produced in the US is dent corn, industrial corn. So it's just produced on such a huge scale. We're finding new uses for it. So, for example, putting it into the LYCRA fibre. At the moment, corn is used, it's used for feedstock, but it's also used for biofuels. The demand for those sorts of things are coming down with the electric cars and the changes in industry. So we're kind of working with the farmers to find a new use for it. And because you've already got the farms there, they're already well established, we don't have to take more land. We're using what's available. So actually, with the amount of corn available, with the scale that we need, it's definitely sort of a resource that's worth us looking at and investing in. And, you know, it gives a perfect product for us. As Chris said, there's no need to re-engineer your fabrics because by the time it gets to us, chemically it's the same. So putting it into the fabrics will give it exactly the same performance. Does that answer your question? Yeah.
No, we're only taking a very small percentage, less than 1% of the total corn production from Iowa into our LYCRA business.
Chris, don't be too harsh on yourself. You guys are iterating, and we will only progress to better if people iterate, which is really important. But I've still not seen hands. Can I ask the audience, please show your appreciation for Chris.